All right, good morning. It is Tuesday, April 7th, and this is the video recording for the lecture on sections 2.3 and 2.4. Again, I apologize for the fact that I was continually kicked out of the Zoom room. I have my wife currently looking into what the problem is by calling NetNitco, and hopefully we won't have this issue next Tuesday. I do want to remind you guys that you have a test on Thursday, and it will open up at midnight Thursday morning, and you will have 24 hours to get that test taken, and you can take it up to twice. All right, so we are going to, I'm going to start the lecture all over again, starting with beginning of 2.3, and I am going to bring in the notes that I have created for this lecture. I want to remind you, that is 2.4, I don't know why it's doing that again, but I want to remind you that the notes are in your Canvas Zoom notes file. So I hope that you will go look at them there. For some reason, it keeps wanting to share the wrong screen. Hopefully it is sharing the section 2.3 with you now. It is showing that on my screen, so I'm going to assume that it's showing that on your screen as well. So when we talk about unions and intersections, these are the two operations of sets that we are going to primarily focus on. When we talk about a union, the union of sets is the collection of all objects that are part of either set. So if we have a couple of sets, A and B in this case, and we want to find the union of them, we take the stuff that's in A, we take the stuff that's in B, and we put it all together. Now, we don't write any repetition, okay? So the key word for union is the word or. When we're talking about a union of two sets, we're talking about the stuff that is in either A or B. So here's an example here. If set A has fox, wolf, and deer in it, and set B has wolf, deer, and raccoon, the union, and by the way, the symbol for the union is this kind of funny looking U, okay? The union of A and B would be the stuff that is in A or B. So the stuff that's in A is fox, wolf, deer. The stuff that is in B is wolf, deer, raccoon. So the stuff that is in A or B would be the fox, the wolf, the deer, the raccoon, because fox, wolf, deer are in A, wolf, deer, raccoon are in B, the stuff that's in either of them. So note that we don't write repetition, so we don't write wolf and deer twice when we put them together. We just write fox, wolf, deer, raccoon. There's no fox, wolf, wolf, deer, deer, raccoon. We don't duplicate, we just write them one time. Now when we talk about an intersection, the key word for intersection is the word and. And the symbol for an intersection is this upside down U. So when we're talking about an intersection, we're talking about the stuff that is in A and is also in B. All right. What do they have in common? What's in both of them? And so using the same sets, fox, wolf, deer, and wolf, deer, raccoon, obviously the items that they have in common are the wolf and the deer. Okay. And so we would write A intersect B, which means the stuff that's in A and B. A intersect B would be wolf, deer, because that's what's in both of them, okay? It's important to understand that. Here's a visual example. I want you to understand that this circle right here on the left is set A, and this circle to the right is set B, and there's overlap between the two, okay? So in set A, we have fox, wolf, and deer. In set B, we have wolf, deer, and raccoon. But what they have in common, what's in both of them, is wolf and deer. So this kind of football-shaped region right here is called the intersection. And that's where both the wolf and the deer would appear in this diagram. It's called a Venn diagram. A Venn diagram is a diagram that we use to visually interpret logical statements. The third term that we need to understand in 2.3 is the complement. Now, the complement of a set is the stuff that's in the universe but not part of that set. So as an example, and I've got the universal set here. The universal set or the universe is all the numbers that exist in this particular problem. So the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all the numbers that exist, okay? Now, set A is part of the universe, and it contains the elements 1, 2, 3, 5, 7. So you can see, here's my universe, the big box is my universe. Here is set A, and set A contains the 1, 2, 3, 5, 7. Now there are numbers that are in the universe that are not part of A. So they go outside of A, but they're still in the universe, so they're still in the blue box. And that's where those numbers appear. And those numbers could go anywhere. They don't have to go down there in that corner. They could go there, they could go over here, they could go down here. It doesn't really matter where we write them. But those are the numbers that are part of the universe, but not part of A. And we call those numbers the complement of A. So the complement, sometimes students think of the complement as the opposite, or they think of it as an inverse. And those words, if they help you understand it, that's okay. They're not ideal expressions of what's really going on. But if they help you to understand what a complement is, then that's fine. Again, I just want to say that the complement is stuff that's part of the universe, but it's not part of a set. So, and if you take set A and you take the complement of A and you put them together, you're going to get the original universe. So if I take everything that's in A, the 1, 2, 3, 5, 7, and I take the complement 4, 6, 8, 9, and I put them together, I end up with my original universe, as you can see right there. So here's an example with letters. In this particular example, the universe is all the letters from Q to Z. Those are the only letters that exist in this problem. Now within that universe, there are 3 sets. There's the set A, which contains the letters Q, S, U, W, Y. Don't know why there's a little parentheses there. We'll take it out. There's set B, which is Q, S, Y, Z, and then there's set C, which is V, W, X, Y, Z. And we want to use this information to solve these operations. Again, these are operations. Intersections and unions are operations. Much like addition, subtraction, multiplication, and division are operations of arithmetic, unions and intersections are operations of sets. Okay? So we're going to look at A intersects C complement. Now, before we can do that, we need to identify what C complement is. And so C complement is everything in the universe, all of this stuff, except for what's in C. Now what's in C is the VWXYZ. So that makes this complement really easy to identify. The complement of C is everything except for VWXYZ. So the complement of C is QRSTU. By the way, it might be a little hard to see there, but there is a little apostrophe in, there was. There it is. There we go. So there is a little apostrophe there. That's the complement. C complement is QRSTU. And then we take our original A, which is QSUWY, okay? And we want to find their intersection. Now remember, intersection means what do they have in common? What is in both A and C complement? By the way, notice I've got C complement written before A. The order in which you do unions and intersections doesn't matter. It is commutative. So what is in both A and C complement? I'm going to write this down here like that. Oh, no, I'm not, because it's just making it a mess. Okay, so the stuff that is in C complement and A, well, they both have a Q in common. They both have an S in common. And they both have a U in common. So the intersection of A and C complement is QSU. All right, that would be our answer. I'm going to put that in bold just so that you can see it a little more clearly. And I'll increase the font size just so it's a little more obvious. So that is the intersection of A and C complement. So when we get to question B here, just like in arithmetic, when we do stuff in parentheses first, we do stuff in parentheses first in sets as well. So we've got this B union C. That means we're going to take everything that's in B, we're going to take everything that's in C, and we're going to put it all together in one. So let's look at that. So B union C is going to equal, well, what does B have? Let's see, I see a Q, and I see an S, and then there's a Y and a Z, but there's also a Y and a Z in C. So I'm just going to put the rest of C in there. So that would be V, W, X, Y, and Z. Oops. And let me widen that just a hair. There we go. So this right here is B union C. All right. Now we know that A is, we just looked at A in the previous problem, so I'm just gonna copy it. So there's A. All right. Columns don't always work so nice. So remember, this is B union C. Oops. Well, the top line is B union C. The bottom line is A. And we want the intersection of the two of them. So we want to identify what they have in common. So clearly, they both have a Q. They both have an S. Oops, hang on a second. It's writing it in the wrong place. There we go. They both have a Q. They both have an S. This has a U and this has a V. So they don't have that in common. They both have a W in common. And they have a Y in common. So this, again, I'm going to bold that. And I'll increase the font size just to make it a little more obvious. Those are the, that is the intersection of A and B union C. All right. So let's take a look at this one here. This last one, a little more complicated. So the first thing we have to identify is B complement. Okay. Now remember, B complement is going to be everything in the universe except for what's in B. So if we go over to our universe, and again, I want to remind you that universe or universal set is this right here, Q, R, S, T, U, V, W, X, Y, Z. So the stuff that is in B complement, the stuff that, in other words, is not in B, well, let's see, it has a Q, so R, why did it jump down there? R, let's see, B has an S, T, U, V, W, and X. R, T, U, V, W, X. That's the stuff that is in the universe, but not in B. So this is B complement. That's the first part, okay? Now we're going to look at C complement. Now we already found C complement in a previous problem. In problem A over here, we found C complement. So I'm not going to spend a lot of time redoing it. I'm just going to copy it and bring it over here. That is C complement. Now, before we go on, we have to find the intersection of those two things. B complement and C complement. The intersection is what they have in common. Okay, so let's see. They have an R in common. They have a T in common. And I think that's it. There's an R, there's a T. Oh, and a U. I missed the U. So they have RTU in common. So this RTU is the intersection of B complement and C complement. I hope everybody sees that. Okay. And now we're going to union that with A. When we union that with A, we know that A, I'm just going to copy it and bring it down. A is this. Okay. And so the union is going to be putting this together with this. So that would be Q, R. Remember, union means what do they, either one of them have. What's in one or the other. So Q, R, S, T, U, W, Y. And let me widen that just a hair. There we go. So that, see if I can raise that. I knew that was going to happen. That's okay. Whoops. Try to make it just a little wider. So it's all on one line. There we go. So this is the union of this intersection and set A. All right. If you can do this one, if you can do letter C without any difficulty, you should be in good shape for doing the doing anything that you see on your test or on your final exam. All right. So keywords from this section 2.3 set operations are unions, intersections, and complements. Very important that you have a solid understanding of those three terms. All right. So now I am going to bring up section 2.4, and we're going to talk about Venn diagrams. Now, section 2.4 is called survey problems, and survey problems use a Venn diagram in order to explain and find the solution to these kind of problems. I do want to point out one thing to you, by the way, before we go on to that, and that is that there are PowerPoints that I have put in the modules on Canvas. This is the PowerPoint for section 2.3, and there are some examples of finding complements and intersections and unions of things. There's a visual representation of set, complement, and so forth. So you can go into the modules section of Canvas, and you can find these. You can ignore differences, you can ignore cross products if they pop up, but you can, in section 2.3, but you can get these Venn diagram, or I'm sorry, these PowerPoints, and you can use them to help you. There are also videos that I posted as well. All right. So now we're going to move on to section 2.4. Let me pull that up here. And we are going to talk about survey problems. And to do that, what I've done is I've created a Venn diagram here with two sets, and I've labeled each of the sections that the Venn diagram is divided into with letters. The letters identify the section. So A is this entire circle, okay? Set A is the entire circle, and set B is the entire circle over here. Now set C is the intersection of A and B, okay? This set C, just like in the previous example we looked at, this set C right here, region C, represents the intersection of A and B. And set D is the rest of the universe except for the stuff that's inside A, B, and C. All right, I hope that makes sense. And then I've put numbers in each of the regions because we're going to determine the numerical values for each region. So what do I mean? Let me explain it. It's not that hard. So let's go ahead and look at set A, okay? In set A, I'm asking which numerical values make up that set, okay? Well, set A is this entire circle. It's not just representative of this region. We use the letter A in that region to break it up and identify all four regions, but set A is actually this entire circle. So if I were to ask you what numerical values represent set A, you would tell me that the number 1 is in set A, but the number 2 is also part of set A because A is this entire circle. I hope that makes sense. Okay, and where did my 2 go? Hang on a second. There it is. Okay, so set A is the numbers 1 and 2. So if I ask you to identify A union B, that would be all the stuff that's in A or in B. All right, so clearly the numbers that are in A and B, I'm sorry, A or B, are 1, 2, and 4. I'm a little bit hoarse. Hope you can deal with that. There we go. All right. So the stuff that is in A or B are the numbers 1, 2, and 4. All right. So the intersection, I already kind of gave this away to you guys. It's probably pretty obvious. The intersection is the stuff that is in A and is also in B. And of course, the only number that is in both A and B is 2. All right. 2 is in the intersection. It's the only thing that's part of both A and B. Now, number 4 asks us to find the complement of A union B. Now, good news, folks. We already found A union B in number 2. All right. We found A union B to be 1, 2, 4. So then the complement of 1, 2, 4 would be everything in the universe except for 1, 2, 4. And it's pretty obvious then that that would have to be the number 3. By the same token, over here in number 5, let me widen this a little bit so we don't run into any issues. We already found the intersection of A and B. In problem number 3, we found the intersection of A and B. So we want the complement of that same intersection. Well, the complement is going to be everything in the universe except for the number 2. So clearly, that would be the numbers 1, 3, and 4. Hopefully that's making sense. And, whoops, in a second here. The complement of C would be everything except what's here. And you can probably notice that, well, wait a minute. If A intersect B is this region right here, which also happens to be C, and we're finding the complement of it, then this is actually the same as problem number 5. It's asking the same question. So then the solution here, the complement of C, is also 1, 3, 4. I hope that makes sense. Now let's apply that in a little more practical manner. Okay, let's look at an example here. So the House of Representatives, we're talking about, you know, in Congress, you know, you've got your Senate and you've got your House of Representatives. The House of Representatives has 435 members, okay? So on a given day, 2 bills were voted on and 200 members voted on bill number 1. That would be all the people in this circle. And then 250 members voted on bill number 2. That would be all the people in this circle. Now I want you to notice, folks, that 200 plus 250 is 450, which is more than the number of people in the House of Representatives. But that's not a mistake, because some of the people, 175 of them, voted on both of the bills. And that means they voted on bill 1 and they voted on bill 2. That means that those people would be in this region right here. These are the people in this region who voted on both bills. So what I'm going to do is I'm going to insert a text box there, and we're going to write in it, okay? So the people who voted on both bills are in here, all right? And that means there's 175 of them, all right? 175 people voted on both bills. Hopefully that makes sense. Now, we know that 200 people voted on the first bill, okay? 175 of them are already accounted for. These 175 are part of this 200. So that means that we need to put the number of people that will bring this total up to 200. We need to put them in this region. Again, I'm going to insert a text box for me to write in. And we're going to put those people here. Now, if 200 people voted on the first bill and 175 of them are already counted, that means there are 25 people left in this region. Okay, now notice that these 25 people plus these 175 people make up the 200 people that voted on bill number 1. Okay, we're going to do the same thing with bill number 2. We know that 175 people have already voted on bill number 2. We know that there are a total of 250 people that voted on bill number 2. So that means that the difference between those 250 people and the, whoops, hang on a second, something weird just happened. Here we go. We're inserting that text box. We know that if 250 people voted on bill 2 and 175 are already counted, that means that there are 75 more people that go in this region. Okay, so notice the 75 plus the 175 equals that 250 people. All right, now, not quite done yet. Let's add these numbers together. 25 plus 175 is 200. Those are the 200 people who voted on bill number 1. So there's 200 people here plus another 75. That's a total of 275 people. But there are 435 people in the House of Representatives. This only accounts for 275 of them. So where are the other people? Where are the other 160 people? They're still part of the universe, but they're not in any of these regions. So that means that they must be outside of these regions, but still in the universe. That means they must be down here. Okay, and we're going to write those people in right there. And how many people are there? Well, I believe that would be, the difference would be 160. I need to make that a little bit bigger so that we can see it a little bit better. There we go. Okay. So that means that there are 160 people. I am going to format that text box to take away the line so that it isn't crossing over. There we go. And I can move it down a little bit like so. All right. So there are 160 people. Let me close this now so we can see it better. There are 160 people down here in this region. Okay. Now, what does that mean about those 160 people? Well, it means that those 160 people did not vote on Bill 1 or Bill 2, which is question A. It says, how many members voted on neither bill? Well, that means that 160 people did not vote on either bill. Maybe they were out of town when that bill was being voted on. Who knows? Okay, but 160 people did not vote on either bill. Question B says, how many members voted on Bill 1 but did not vote on Bill 2? Well, that would be these people. These people voted on Bill 1 and Bill 2. These people voted on Bill 1 but not Bill 2. So that means there would be 25 people who voted on the first bill but not the second. Hopefully that makes sense to you as well. All right. And again, if you have any questions about how I got these numbers, or you need me to walk through this problem again with you individually, please send me an email. I could probably, without any difficulty, set up an individual Zoom meeting to meet with you if you wanted to do that in person, or we can just email back and forth. All right. Now, you're going to have a problem like this on your final exam. Okay. And you're going to have a problem like the next one on your final exam. You're also going to see a problem, some problems like this on your test coming up on Thursday. So we're going to look at a Venn diagram now with 3 circles, okay? It's in your notes. It's in section 2.4. It says, in an exit survey of 280 people at the Museum of Science and Industry, people were asked about the exhibits they visited while they were at the museum. And the results were as follows, okay? So we know that 48 people visited the submarine, and 58 people visited the coal mine, and 34 people visited the Space Center. We also know that 14 people visited both the submarine and the coal mine, 12 people visited the coal mine and the Space Center, and 11 people visited the submarine and the Space Center. And oh, by the way, there are 4 people that visited all 3 of those exhibits. So we create a Venn diagram down here that includes those 3 exhibits. Here's the submarine, here's the coal mine, and here's the Space Center. All right. And then we've got a series of questions. How many people visited exactly 2 exhibits? How many people visited only the submarine, and so forth? So what we need to do is we need to take this information up here, and we need to find a way to get it into the Venn diagram so that we can interpret and answer those questions. Now, folks, here is the best way to do this. You always want to start in the middle if you can. This is kind of a rounded triangle region right here, if you will. That's the intersection of submarine, coal mine, and Space Center. These people that are in this group are the people who went to all 3 exhibits. And they tell us right here that 4 people visited all 3 exhibits. So we're going to put a 4 in there, okay? I'm going to insert a text box and I'm going to write things in there. So we're going to put a 4. Hang on a second. We're going to put a 4 right in here. If it will let me, draw a text box. There we go. We're going to put a 4 right in there. Okay, and of course it's going to look a little off. You're not going to see the background as well, but that's okay. You get the idea. So these 4 people visited all 3 exhibits. Hopefully that makes sense to you. Now we're going to work our way backwards. Okay, we're going to work our way up the chart. Now it says that 11 people visited the U505 and the Space Center. Now those 11 people, here's the U505, here's the Space Center. those 11 people are going to be in this football-shaped region right here, okay? Those 11 people are going to go in here. We've already counted 4 of them. So that means that we are going to have the rest of the people in here, okay? If there are 4 people in here and there are a total of 11 people in this, these 2 regions combined, people who visited the U505 and the Space Center, that means that there are 7 other people in that region, okay? So the 11 people that visited the U505 and the Space Center, there's a total of 11. Now 4 of them also visited the coal mine, but these 7 people visited the U505 and the Space Center exclusively. So now we're going to move up, and it says 12 people visited the coal mine in the Space Center. Now those 12 people are going to go in this region right here, okay? So I'm going to, again, put in a text box right here. And remember that a total of 12 people are going to go in these 2 regions combined. We've already counted 4 of them, so that means there are 8 people in that region, okay? Hopefully this is making sense to you. Now remember, there's a total of 280 people, and we're identifying the regions in which those 280 people went to these exhibits. Excuse me. So moving up again, it says 14 people visited the U505 in the coal mine. So those 14 people are going to go between these 2 regions because these are the people that visited the U505 and the coal mine. And again, we know that 4 of them are already counted. So that means we've got to put the remaining people from that 14 in here. And of course, if 4 are already counted, that means that 10 of them would go in that region right there. So we've already accounted for 10 and 4 is 14, 14 and 7 is 21, and 8 is 29. We've already accounted for 29 of the 280 people. All right. Now we need to continue to account for the rest of them. Now it says 34 people visited the Henry Crown Space Center. Remember that number 34. I'm going to expand this if I can. There we go. We can see it a little bit better. 34 people visited the Henry Crown Space Center. Those 34 people are going to be accounted for in the circle for the Space Center, okay? So we're going to put a text box in the only region that's left for the Space Center, which is right here, okay? And remember, a total of 34 people are in this circle. We've already counted some of them. 7 and 4 is 11, and 8 is 19. We've already counted 19 people. And so the number that goes in here is the difference between the 34 people that visited the Space Center and the 19 we've already counted. And of course, that difference would be 15. So that means there's 15 people in that group right there. I hope that you're tracking with this. It's simple arithmetic. It's subtraction, folks. It's not too bad, okay? So now we know that we've got our 34 people. If you add these numbers together, those 34 people visited the Space Center, just as it says up here. It says 58 people visited the coal mine. So the people that visited the coal mine are in this big circle right here. And there are a total of 58. Now we've already counted 10 plus 4, 14, plus 8 is 22. We've already counted 22 people. So we need to put the difference between the 22 people. Oops. We need to put the difference between the 22 people that we've already counted and the 58 people that visited the coal mine. We need to put that in here. And of course, if you take 58 and you subtract the 22 that we already counted, that means that there are 36 people in there. 40, 58. Yes, that is correct. Okay. And I'm a little OCD. I like my boxes to be a little bit more square. So let me fix that. All right. And then the last thing is that 48 people visited the U505 submarine. Now we've already counted some of those people. All right. We've counted, let's see, 10 and 4 is 14 plus 7. We've counted 21 of them. So that means that if 48 people visited the submarine and we've already counted 21 of them, that means that there are 27 people that we haven't accounted for. So there's 27 and 7 is 34. 34 plus 4 is 38 plus 10 is 48. So that's the 48 people that visited the submarine. All right. Now, you might think that we're done at this point. Okay. But you would be mistaken. Because if you add together all of these numbers, if you had 27 and 10 and 4 and 7 and 15 and 8 and 36, it is not going to add up to the 280 people that were at the Museum of Science and Industry. Okay? So did we make a mistake? No, we did not make a mistake because believe it or not, excuse me, there are people who went to the museum, but they did not visit any of those 3 exhibits. Those people need to be accounted for, and the number that we get for them is going to go outside of the 3 circles. So we're going to put in one more text box, like so. I'm going to put it down here. Okay. Now the number that goes in here has to be 280 minus the total of all these people. So we're going to go ahead and count up all these people. 27 and 10 is 37. 37 plus 7 is 44, plus 4 is 48. 48 plus 8 is 56. 56 plus 36 is 92. And 92 plus 15 is 107. So this is 107 people accounted for. There were a total of 280 people that went to the museum that day. We just counted 107 of them. That means that there are 173 people that were not accounted for that went to those other exhibits. So now if you add all these numbers together, you get a total of 280. At this point, you can then answer these questions below. So let's do that. It says, how many people visited exactly 2 exhibits? Exactly 2 exhibits would be the people who visited the U-505 and the coal mine, or the U-505 and the Space Center, or the coal mine and the Space Center. So it would be the people in here, and here, and here. Those 3 groups of people visited exactly 2 of the exhibits. I hope that makes sense to you. And 10 plus 7 plus 8 is 25. So there are 25 people that visited exactly 2 of the exhibits. The next question is, how many people visited only the submarine? Now, the people that only visited the submarine are the people in this box right here. These people visited the submarine, but they did not visit the coal mine or the Space Center. So, of course, that number is 27. Now, we need to be careful. Letters C and E are very, very similar. So we're going to be very careful with them. Letter C says, how many people visited the Space Center and the coal mine? Okay, both of them, the Space Center and the coal mine. Okay, we know these are the people who visited the Space Center and the coal mine right here. These people and these people visited the Space Center and the coal mine. But notice it says, but not the submarine. Okay, so when we look at these 2 groups of people, these people visited the submarine as well. So we're not going to include them. Okay, we're only going to consider these people because these are the people who visited the coal mine and the Space Center. They did not visit the submarine. So that number is 4. Now I'm going to skip down to letter E, and then we'll come back to D, because letter E says how many people visited the Space Center or the coal mine, but not the U-505 submarine. This said and up here. Does everybody see the difference between these 2 problems? This is very important, the difference between and or. So how many people visited the Space Center or the coal mine, but not the submarine? So let's look at all the people. Let's look at the people who visited the Space Center or the coal mine. These people visited the coal mine, okay? And these people visited the coal mine. These people visited the coal mine. These people visited the coal mine. These people visited the Space Center, as did these people, and these people. So these are all the people that are highlighted who visited the coal mine or the Space Center. Okay, hopefully that makes sense. But we need to exclude the people who visited the submarine. We don't want the people who visited the submarine. So that means these people are out, these people are out, and these people are out because they also visited the submarine, which leaves these three groups right here. These people visited the coal mine or the space center, or could mean both. If you ask these 8 people, did you visit the coal mine? They'd say yes. Did you visit the space center? They'd say yes. Okay, so they're included. So it's those 3 groups of people who visited the coal mine or the space center, but not the submarine. So that total would be 36 plus 8, that's 44, plus 15 is 59. So that answer right there would be 59. How many people, let's go back to letter D for a moment. How many people did not visit any of these 3 exhibits? Well, that's an easy one. These people right here, they went to the Museum of Science and Industry. Why they would go to the Museum of Science and Industry and not hit the 3 of the biggest exhibits there, I don't know, but these people did. And that was 173 people who did not visit any of the 3 exhibits. And then the last question is, how many people visited the Space Center or the submarine? Space Center or the submarine. It doesn't exclude anything. So let's look at the people who visited the Space Center or the submarine. These people visited the Space Center or the submarine. These people visited the Space Center or the submarine. These people visited the Space Center or the submarine. These people visited the Space Center or the submarine. So did these people, and so did these people. These are the people that if you ask them, you could ask any of these people, did you visit the Space Center or the submarine? These people would say, well, yes, I visited the submarine. These people would say, yeah, I visited both. These people also visited the Space Center or the submarine. Now, these people here did not visit either of those. And these people did not visit either of those. So how many people visited the Space Center or the submarine? We add up the highlighted ones. 27, 37, 41, 48. 48 plus 8 is 56, plus 15 is 71. So that would be 71 people who visited the Space Center or the submarine. I hope that those answers make sense to you. Okay? I'm going to leave that there. I'm going to save this and I'm going to upload this as new notes in the Zoom notes in our Zoom folder. All right? So I hope that you were able to follow that lesson. There are some really good examples in the videos and the PowerPoints that are loaded online. I want to remind you that your test is on Thursday, and you will have 24 hours to take that test. You can take it up to twice. And I will go through and evaluate your tests to see if there's any partial credit I could give that the computer might not have given. So your grades could go up, but they will not go down. If you have any questions, you can reach out to me via email. I can even set up an individual Zoom meeting with students if you want to do that. Chris is having his SI session tomorrow night, Wednesday, April 8th at 5 o'clock from 5 to 7. And after that, he will not be available to answer any questions. So I encourage you to get in there and visit with him if you have any questions. My wife is busy talking to NITCO to find out what the problem is. If I cannot get this home internet issue resolved, then we will continue to have Zoom meetings, but I will have to drive to the university and do them from there because they have a stronger internet connection. I apologize for the inconvenience of having to do this video lecture without your interaction, but hopefully it served you well. If you have any questions, please do not hesitate to reach out. I will be available on my computer via email pretty regularly over the next 48 hours. All right, I hope you're all safe and healthy and doing well, and I will talk to you later.